This lesson is on the properties of addition and multiplication. Hopefully you learned a little bit about this last year. We'll review some of them right now and just do some examples of each one so that we can make sure that we all are on the same page and we can understand which properties are going to help us later on when we're starting to do more complex math problems. So let's start with the additive identity property right here. It's also called the identity property of addition. The idea is you can add something to a number to keep its identity. So let's say we have the number 5. Can you guys tell me, what are you going to add to 5 to keep its identity, to keep it the same? You're going to add 0, right? So 5 plus 0 keeps its identity. It keeps it 5. That's the additive identity property. So we also have a property of identity property for multiplication. What if we had 5, what would we multiply 5 by to keep its identity, to keep it the same? We wouldn't multiply it by 0, we would multiply it by 1. Absolutely. So 5 times 1 is 1, it keeps its identity. So that's identity property of addition and multiplication. Now let's stick with multiplication. A multiplication property of 0 tells us, let's say we start with 5 again, if we multiply any number by 0, what's it going to give us? 0. That's actually a property name. Now that seems kind of common sense to us at this point, but there is a property that we call that, multiplication property of 0, to describe what happens in that situation. Okay, the next 4 down here, I'm going to move this up. The next 4 are commutative properties and associative properties. And both of these work for addition and for multiplication. Addition and multiplication. And we'll see in a minute why you think they don't work for subtraction and division. The commutative property of addition, let's do a different color just for fun here, says that if you have something like 2 plus 3, we can switch around the order of what we're adding and it doesn't change anything. So 2 plus 3 is exactly the same thing as 3 plus 2. We can switch around the order. I like to do this little arrow symbol so I remember, hey, I'm just flipping the numbers, flipping the order, and it keeps the answer the same. Same thing works for multiplication. If I have 2 times 3, isn't that the exact same thing as 3 times 2? So that's the commutative. Is this sounding familiar? One thing I want to point out, commutative. 2 T's. We hear a lot of people saying commutative with an N in there. No N, commutative. Say it with me. Commutative. Commutative. All right. Then we get to the associative properties of addition. This means, let's say we have 3 things that we're adding up together. If I have 2 plus 3 plus 4, that, I can put parentheses around the 2 plus 3. And the order of operations would tell me I'd have to do that first. So I'd have to do 2 plus 3 first, which is 5, plus 4 is 9. But the associative property tells me that I can actually put those parentheses anywhere. I could put parentheses around the 3 plus 4, and I'd still get the same answer. So 3 plus 4 is 7, plus another 2 gives me 9 as well, which is the same as the 9 that we have over here. So that's the associative property. It means you can move around the parentheses wherever you want to in the problem. So I'm going to put a little parentheses around there just as my little reminder that's moving parentheses around. And then the same thing happens for multiplication down here. 2 times 3 times 4. That would be, you'd have to do the parentheses first. 2 times 3 is 6, times 4 would give us 24. What if we put the parentheses in a different place and did this? We'd have to do 3 times 4 first, which is 12, times 2 is still 24. So associative properties are moving parentheses. I like to think about that as you can associate with different groups of people at different times, and you're still you. So the parentheses, it doesn't matter where they are. That's the associative property. This one is my absolute favorite. Move this guy up. The distributive property. Oh, by the way, before we go on to that, can you see why commutative and associative wouldn't work with subtraction? Is 2 minus 3 the same thing as 3 minus 2? No. Okay, what about division? 2 divided by 3, same as 3 divided by 2? No. and so it won't work here either. So that addition and multiplication are unique in that you can use this commutative and associative property with them. Okay, back to the distributive property. This one includes both multiplication and addition. So as we do practice today, if you see a property where there's multiplying and adding going on in the same expression, it's going to be the distributive property. The distributive property says if you've got something, let's use these examples, something like this. Okay, I've got 4 plus 5 in parentheses and a 3 on the outside. We know if there's nothing in between the 3 and the parentheses, what does that mean? Means multiplication. So it's really like there's a multiplication sign here. But I can't just go ahead and multiply 3 times 4 because the 4 plus 5 is in parentheses. So if I were to follow the order of operations on this, what's 4 plus 5? That would be 9. 9 times 3 is going to be 27. Okay. There's another way that I can actually go about giving an answer for this expression right here, simplifying the expression. The distributive property says if you're multiplying something on the outside, you can multiply it by the first number on the inside plus multiply it by the second number on the inside. It looks like this. 3 times 4 right here, 3 times 4 plus 3 times 5. Okay, now let's just double check and make sure we agree with that. What did I say the answer was back here when I did the order of operations? 9 times 3 is 27. Well, what would this be? 3 times 4 is 12. 3 times 5 is 15. And 12 plus 15 gives me 27. So the distributive property gives me a different way to look at this and break it apart into 2 multiplication problems. And that is going to be super useful to us throughout the year.